8 minutes paper, light it bright. 8 minutes privacy research insight. 8 minutes paper, feel the spark. 8 minutes privacy making it smart.
Okay, let's unpack this. Welcome, everyone. Today, we're diving headfirst into the truly incredible progress in text-to-image generation, T2I, as it's often called. We're talking about how AI can turn your words into these stunning visuals, and specifically how a brand new framework called Parrot is really pushing the boundaries on image quality. Here's the core insight, really. Parrot seems to crack the code on making AI images consistently better. It does this by teaching the AI to balance multiple ideals simultaneously, sort of like a human artist would, rather than just chasing one goal. Now, you've provided us with some fantastic source material for this exploration, essentially a deep research paper. It's titled Parrot, Pareto-optimal multi-reward reinforcement learning framework for text-to-image generation. And this isn't just any paper. It's a big collaboration. We're talking Google Research, DeepMind, OpenAI, and several universities all working together. When I saw that list, my first thought was, okay, they're really aiming high here. So our mission today is to pull out the absolute core insights from this research. We're going to focus on how Parrot aims to create images that aren't just, pretty, but also more accurate to your prompt. And get this, even more emotionally resonant. This isn't just about making nice pictures. It's like watching AI start to truly understand and, well, express nuanced creative intent. Think about it. How often have you seen an AI image that just isn't quite right, even with a decent prompt? Parrot aims to fix that.
Yeah, and what's fascinating here is how they tackled these really persistent quality issues. Because, while models like Image and Stable Diffusion, they've made huge strides, truly impressive stuff, they still often struggle with fundamental image quality. Things like poor composition, maybe objects missing from the prompt, or just a general lack of, let's say, aesthetic appeal. Parrot is designed to address exactly those challenges head-on. It feels like a jump from good enough to potentially genuinely high quality.
Right. So let's talk about why this is so hard. Why is creating that perfect AI image such a persistent challenge? What's the core difficulty? Those images, maybe the subject is cropped weirdly, or something you asked for is just missing, or it just feels flat, lacks spark. It's a common thing, right? And earlier models, like, say, Stable Diffusion 1.5, they often show these issues pretty clearly. It's almost like the AI gets the main idea, but none of the finesse.
Exactly. And if you look at the bigger picture, previous attempts to fine-tune these models using reinforcement learning, RL, they often relied on pretty simple methods. Typically, they'd use what's called a weighted sum of different quality metrics. So you try to balance, aesthetics and how well it matches the text by just assigning weights, like 60% this, 40% that. The problem is, well, first, manually adjusting those weights gets really impractical as you add more criteria you care about. And second, optimizing hard for one metric can actually hurt the others. There was prior work, like Promptist, that also used the sum of scores, but it just wasn't flexible enough for the complexity of what makes an image good to a human,
Okay, so that weighted sum approach is brittle. If that's the hurdle, then Parrot comes in as the solution. And its big innovation is this multi-objective optimization, moving beyond just one thing, or even that simple weighted combo. It's a different way of thinking.
Indeed. Parrot's real cleverness is in its approach to Pareto-optimality. Now, in simple terms, instead of just trying to max out one quality score, Parrot aims for the best possible trade-off across multiple quality rewards, all at the same time. So imagine the AI generates a batch of images. Each one has a different mix of qualities, maybe great aesthetics but poor text match, or vice versa. Parrot doesn't try to learn from all of them. Instead, it identifies what they call the non-dominated points in that batch. These are the images where you basically can't improve one quality without making another one worse. They represent the best available trade-offs. By focusing its training only on these non-dominated images, Parrot automatically learns from this optimal balance. It's kind of learning a much more sophisticated, balanced definition of good.
Which raises a really interesting question, doesn't it? How do you even train an AI to understand balance and trade-offs in something as subjective as art or image quality?
That's the core of it, is learning nuance.
And to get that nuance, Parrot focuses on 4 key quality metrics it's trying to optimize simultaneously. First, there's aesthetics, just the overall visual appeal, how beautiful it looks. Second, human preference, which is exactly what it sounds like. What do actual people prefer when they compare images side by side? Third, text-image alignment. How well does the image actually match the words you typed in? This is where things like CLIP scores come in, measuring that semantic similarity. And finally, image sentiment. Does the image evoke positive emotions? It's trying to capture that feeling, not just the content. So it's a really comprehensive view of good, not just technically right, but emotionally right too.
Yeah, it's a much richer target. And beyond just the multi-objective part, Parrot uses this unique joint optimization strategy. This is pretty different. See, previous work might fine-tune the main T2I model, or they might fine-tune something called a prompt expansion network, but usually in isolation. Parrot fine-tunes both of them together simultaneously.
Okay, hold on. Let's break down that prompt expansion network, or PEN. What's that doing, and why is tuning it together with the image generator so important?
Right, the PEN is actually really neat. It takes your original prompt, which might be quite simple, like a cat reading a book, and it intelligently expands it into something much more detailed and richer. So it might become a fluffy ginger cat wearing spectacles, deeply engrossed in reading a leather-bound book in a cozy, sunlit library nook. It adds all that descriptive detail. The PEN itself uses a pretty powerful language model in this case. They mentioned using Polym2LIT to generate these richer prompts. Think of it like an AI assistant automatically adding descriptive flair to your basic idea.
Ah, okay. Like an automatic prompt enhancer.
Exactly. And this is where that joint optimization really shines. By tuning both the PEN and the T2I model together, you're basically encouraging the PEN to create prompts that are not just more detailed, but detailed in ways that help the T2I model make better images. And the T2I model gets better at using these rich prompts. It's a collaborative process. The paper even shows, I mean, it's figure 11, that if you tune just the TCN or just the T2I model alone, the results aren't nearly as good.
Yeah.
It really highlights why doing both together is so powerful. It's synergistic.
So what really stands out to you about how this combination, this joint tuning, might lead to genuinely better images? Is it just more detail or something else?
Well, it's more than just detail. It's about making the whole system smarter, end to end. The PEN learns to generate prompts that play to the T2I model's strengths, you could say. And the T2I model learns to better interpret and render these richer, more specific instructions. It becomes a kind of positive feedback loop. Each part helps the other improve, leading to a higher overall quality ceiling. It's like they're learning to dance together rather than one following the other awkwardly.
Okay, that makes sense. But there's another clever bit here, right? Something called original prompt-centered guidance. Because I can see a potential problem. If the PEN adds too much detail, maybe a main thing you ask for gets kind of lost. Like, you ask for a Shiba Inu, and you get this amazing detailed landscape, but the dog is tiny in the corner.
Exactly. That's a real risk with prompt expansion, diluting the original intent. So this guidance mechanism is crucial for keeping things on track, maintaining fidelity. What happens is, during the image generation step, the T2I model uses guidance from both the simple original prompt and the fancy expanded prompt. It's a linear combination, essentially blending the guidance signals. This balance ensures the final image stays true to your core request, keeps the main subject prominent while still getting all the benefits of the added descriptive richness from the PEN. The paper has examples, like in Figure 9, showing how even with a very descriptive expanded prompt, the Shiba Inu stays clearly the focus. It keeps the star of the show in the spotlight.
Okay, this all sounds very promising conceptually, but theory is one thing. Let's talk results. The proof is in the pudding, as they say. They ran a lot of experiments, user studies. What did they find?
They did. And the quantitative results, looking at things like Table 1 and Figure 4 in the paper, are pretty compelling. Parrot consistently showed significant improvement across all 4 of those quality metrics we talked about: aesthetics, human preference, text-image alignment, and image sentiment. It clearly outperformed the baselines they compared against, like standard Stable Diffusion 1.5, and also methods like DPOK, which uses that basic weighted sum approach, and Promptist too. What's particularly interesting if you look at the training curves is that Parrot shows these stable increases across all the metrics together. Whereas the weighted sum methods often show that trade-off problem. Clearly you push one metric up, another one might actually go down. Parrot seems to lift the boat for all of them, which is quite impressive.
And it's not just the automated scores, right? What did actual humans think? Because that's often the real test for image generation. The user studies seem really important here.
Absolutely crucial. And the results there, shown in Figure 5 and Table 2, were very strong too. Human raters consistently preferred the images generated by Parrot. Across all the criteria they were asked to judge on, Parrot's images came out on top. So it's not just a technical improvement measured by algorithms, it translates into images that people genuinely find better, more appealing, more accurate.
It really validates the approach, doesn't it, if people actually like the output more?
It does. And there's another cool feature related to user control: reward-specific preference prompts. This allows the user to kind of nudge the model during generation. By adding a specific tag, like Reward 1 for aesthetics or Reward 3 for text alignment, right at the start of your prompt, you can tell Parrot to prioritize that specific quality a bit more. Maybe you want something super aesthetic, even if it bends the prompt slightly. Or maybe perfect alignment is critical for your use case. You can influence that trade-off. But crucially, as shown in Figure 7 and 8, Parrot still maintains a good balance. Unlike simpler methods where pushing one reward might tank the others, Parrot adjusts the trade-off more gracefully. It offers users unprecedented, nuanced control.
Wow. Okay, so you can almost dial in what kind of good you're looking for. That's pretty sophisticated.
It really is. It makes it feel less like typing into a black box and more like collaborating with the system.
Okay, so let's try and synthesize this. Parrot's big impact seems to be this novel multi-reward optimization algorithm. It uses that Pareto-optimal selection idea, focusing on the best trade-offs, and it combines that with the joint optimization of both the image generator and the prompt expander. And the result is, well, consistently higher quality images that are more detailed and also more faithful to what you actually asked for.
Yeah.
That feels like a significant step up.
I think so too. If you zoom out a bit, Parrot represents a really significant step forward in AI's ability to grasp and then execute on nuanced creative intent. It's learning to balance multiple goals at the same time, which is, much closer to how a human artist or designer works. They're constantly making trade-offs, composition versus color, emotion versus literal representation. This kind of thinking, this multi-objective approach, could have really big implications for generative AI well beyond just images.
That actually leads perfectly into a final thought, something for you, the listener, to consider. Given these advancements like Parrot, which rely heavily on how well we can define and measure things like aesthetics or human preference or sentiment, what new kinds of digital creativity or maybe even practical applications we haven't thought of might open up as these underlying quality metrics get better and more refined? If we get better at telling the AI what good means, where could that lead?
It's a fascinating question, and just to round that out, it's also important, as the researchers themselves note in their societal impact statement, to remain mindful. This increasing power to generate very specific, high-quality content, even with the best intentions, carries risks. Risks of misuse, certainly, but also the potential for inheriting and amplifying biases from the training data or the reward models themselves. It's something the field constantly needs to grapple with as the tech gets more powerful.
A really important point to end on. Thank you for watching. If you like our content, please subscribe to our channel. We will see you next time. Bye.